Hi everyone. In the previous classes, we have seen the concept of flip-flops, right? Basically, flip-flops are meant for to store a bit of information. Means it can act as a kind of a memory element, right? So this is one of the advantages of flip-flop. We can able to use it for further, which can be used for to count the numbers. To count the numbers. I mean, basically, if you are going to use flip-flops, right? If I take any kind of flip-flop, like for example, let me call it a kind of a T flip-flop, right? I'm going to give the input, and based upon the way you are passing the clock signal, this T flip-flop is going to behave, right? For this, we are going to write some kind of timing diagram also, right? When you are going to write the timing diagram, you can able to observe various kind of clock pulses, how they are going to behave based on the inputs you are trying to change. I mean, if you take in T flip-flop, if you are going to give the value 0, the next state will be the present state, that is latch mode. If you are going to have the value 1, it is going to be toggle state, right? Given toggle state, right? This is what you know, right? Yes. So once you have visualized the timing diagram of any kind of a flip-flop, where you can able to observe some kind of clock pulses like this, right? So depending upon like whether it is negative edge triggered or positive edge triggered or level triggered, like that, based on that it is going to vary. For example, if I write like this, what is the meaning of this one? You can able to observe the meaning of this one is I am trying to apply the clock signal at the negative edge level, negative edge, right? That's the reason it is going to change its value. I am trying to say something, right? At the value of negative edge, it is going to be toggle its value, right? As it is low, it has toggled to high. As it is high, it has toggled to low. As it is low, it has toggled to high. now you can able to count these clock pulses also. You can able to count these clock pulses. The way it is counting can able to having meaningful name, right? So meaning that we can able to count the numbers, like those numbers from starts with 0 to 1 to 2 to 3 and 4 and so on. Depending upon the way you are trying to implement the counters, they will represent that kind of a counter. Or it can be from, for example, maximum value is 4, 3, 2, 1, 0 and so on. Like whatever it may be kind of a random order also. It can be kind of a random counter also. Or it can able to have something between, not only starts with 0, not only starts with the maximum value, it can starts with 1, it can starts with any number, it can end with any number, and it can able to have some kind of looping mechanism. So like that, we are going to have various kind of counters are there. Those are all the things that we can able to use with the help of these flip-flops, right? So if you are going to have the flip-flops, the another advantage of flip-flops is used for the purpose of counting, right? So this kind of flip-flops we can call it as basically a kind of counter sum, right? So the way you are applying the counters will produce the respective kind of outputs. It's not only about the counting, we can able to use it for various kind of frequency divisions. Frequency division, I mean, if I am going to apply some kind of signal at this particular point, for example 4 megahertz, this signal, if I are going to pass it to another kind of flip-flop, like assume that it is a kind of T flip-flop, it may change its frequency, right? So as it moves from flip-flop to flip-flop, it may change its frequency. For example, if I say that 4 megahertz, it may reach it to here 2 megahertz. If I am going to give it to some other kind of a flip-flop, it may reach it to 1 megahertz, right? That depends upon the way you are trying to apply the signals. Right? So the another advantage of these flip-flops is meant for the frequency division also. Right? Yes. So if you are unable to understand anything so far, with the help of the examples, you can able to clearly understand. Okay, now fine. So now in this class, we'll start with the counter sum. Counters, right? So basically, counters means it can be a kind of a sequence circuit only. It can be a sequence circuit which is used for to perform counting operation. counting operation. That counting can be either up counting, or it can be a kind of down counting, or it can be a kind of random counting also. Random up counting means what? It is going to start with some value, something like k. It is going to increment its values from and by 1 or some kind of count, right? Yes. Similarly, down counting means it is going to start with some value, something like, for example, n, and it is going to decrement by 1 or some again l or m value, right? N minus 1, n minus 2, and so on. Random counter means it is going to have random set of values. Like this, we are going to have counters. So means counters are generally, if you try to observe in some kind of technical definition, these are going to follow some kind of predetermined sequence, predetermined sequence of binary states, and these predetermined sequence of binary states are going to be happen when you are going to apply various kind of clock pulses. Various kind of clock pulses, I can call it as counters. Okay, I mean, for example, if I say that if I am going to have a counter, that counter can be implemented in any way. You can able to implement with the help of any kind of flip flop. For example, if I try to implement with the help of JK flip flop, I can able to implement that, right? For example, if you are able to observe, if I try to draw this circuit, so JK flip flop, J is input, K is the input, and some kind of clock signal I am trying to apply. If I am going to apply negative edge triggered signal here, it is going to produce some kind of output, right? So this output, if I am going to call them as Q0, and this will be Q0 bar. And if I am going to combine with another kind of flip flop, again the flip flop is a kind of a JK flip flop only. Suppose this input I am going to pass it to here, pass to here, it is going to produce a certain kind of output, Q1 bar, right? Yes. Now what I will try to do now, I am going to pass some kind of input as 1, right? So you have to pass the values for these JK inputs, right, externally. So I have passed the value as 1. Now try to observe how it is going to behave, right? Don't worry about this, how you are going to write this circuit. In further class you can able to understand, right? For time being I am trying to explain what is the meaning of a counter, right? So this is a kind of one JK flip flop, that is flip flop 1. This is a kind of one more flip flop, that is flip flop 2. Now how it will count its values? If you are able to clearly observe, when you are going to pass the value 1 and 1 to the inputs of J and K, the same 1 will be available here also. Then if I am going to apply negative edge trigger, right, this flip flop is going to be activated when you are going to apply the negative edge trigger. So what I will try to do now, I will try to explain with respect to a kind of timing diagram, so that you will get clear idea how it is going to behave. If I am going to have clock signal like this, for example, let me call these numbers as 0, 1, 2, 3, and so on. If I am going to have 4 like that, right, you can able to have a complete clock signal. Yes, clock, right? Now I would like to show the timing diagram for this negative edge triggered flip flops, right? So when your output may change at the negative edge. Yes guys, so try to observe here. So when you are going to have a kind of JK flip flop for the input of 1 1, right, we are trying to check for 1 1. So when you are going to have 1 1, you know already the characteristic table of JK flip flop, right, or function table of JK flip flop. For JK flip flop, when you are going to have 1 1, what might be the next state? Next state will be the toggle state. For example, if I say that Q0 presently at the low level, if I say that Q0 presently at the low level, I will try to trigger when it is going to have edge triggering. Yes, edge triggering, and it will continue until the next level edge triggering, negative edge triggering. So it will start continuing, and it will come, and it will up, again down, again up, and continues. Right. This is what the Q0 output. What is happening? Similarly, if you try to observe what is Q1, Q1 Q1 is the output which depends on the flip-flop one, right? So Q0 input is giving to Q0 clock signal is giving to the flip-flop 2. So how can we define the Q1 if you are able to observe? So the Q1 you can able to define with respect to Q0. So where is the negative edge signals are there? This particular point of time, negative edge signals are there. So your flip-flop is going to trigger at the negative edge signal. So it will be look like this. That's it. Yes guys, so this is Q0 and this is Q1. If you are able to observe clearly, this is, if you say, one clock signal, or we can say that this is one time period, right? So time period is having one clock. So time period having here one clock. But whereas coming to here at this particular scenario, if I say one clock will be comes under 2 times of the actual clock. Am I right? So if I say the actual clock is this entire thing at Q0, which you got as 2 times of the clock signal, 2 times of the actual clock signal. This is what you can call it as time period at Q0. Whereas coming to, if you take at the Q1, if you are able to observe this entire thing, this is one clock, right? At Q1, this entire class is equivalent to 4 times of the actual clock. If you are able to observe, this is a clock from here to here. This is 4 times of the actual clock. So here time period equal to 4 times of the actual clock. I hope understood clearly, right? Yes. Fine. So before going further, like what is the meaning of frequency division here? Let me try to go with counting. Guys, if you are able to clearly observe, I am trying to mark what is one clock signal here. This is one clock signal, and this will be another clock signal, and this will be another clock signal, and this will be another clock signal. So I will try to redraw one kind of vertical line. Okay, I hope everybody understanding. So what I am trying to do now, see, observe, I will try to write some values, right? So this is 0, this is 1, 1, 0, 0, this is 1, 1, and this is 0, 0, 0, right? So if you are able to clearly observe, this is 0, 0, 0, 0, 1, 1, 0, sorry, it should be 1, 1, this will be 0, 0, right? Yes. If you are going to take the values of this one, this entire clock pulse, what is the value of Q0? Q0 value is 0, Qn value is 0. What about this one? This is 1 and this is 0. This is 0 and this is 1. This is 1, 1, 0, 0. Meaning that for the given clock signal, if I am going to write, if I take the clock signal, if I am going to write Q1 and Q0, right? So if I take this entire thing as one unit, so I will take this as 0, this as 0, this entire thing as 1, this entire thing as 0, this entire thing as 0, this entire thing as 1. Why I have taken like that? Because this will be comes under one clock signal. Now try to observe. So this entire thing will be considered as 1, this entire thing will be considered as 1, and this will be 0, and this will be 0, and so on. It will move, right? Now try to observe what is the value of, see, at clock signal 0, at clock 0, try to observe. This is, I think it is clumsy at this point, but make sure concentrate. This is one clock signal, right? This is one clock signal. At clock signal 0, what might be the values of Q1 and Q0? 0 and 0, right? When I am going to apply one more clock signal, when I am going to apply one more clock signal, what might be the values here? 1 and 0. So when I am going to apply the second clock signal, that is clock number 1, what might be the Q1? 0 and 1. When I am going to apply one more clock signal, what might be the values? 0 and 1. So the next clock signal is number 2, and Q1 is 1, Q0 is 0. If I am going to apply one more clock signal, that is clock number 3, what might be here? 1, and this will be 1. If I am going to apply further clock signal 4, here we are going to get 0, 0, and so on. You can able to further continue this one. You can able to further continue, right? Yes. If you are able to further continue, see, observe what is happened here. At the clock 0, Q1 and Q0 are 0, 0, clock 1, 0, 1, clock 2, 1, 0, clock 3, 1, 1. When you apply the next clock, again it has repeated. So instead of writing like this, I can go for writing like this. If I am going to apply next clock signal, you are going to be repeated, right? So if you are able to observe, this is what kind of counter? It is how it is counting. It is counting from starts with 0, and if I am going to take like this, starts with 0 and it will move for 1, it will move for 2, and it will move for 3. Again from 3 onwards, again it will get back to again the state. So this is what we can call it as up counter. It's a kind of simple example. Why we are trying to why the flip flops are used for the purpose of counting. That is what. It's a kind of up counter, right? So if, in other words, if I say this as a kind of frequency division also. Why frequency division? For example, let me take here the clock signal is 4 megahertz. 4 megahertz. If I am going to apply the clock signal 4 megahertz at this point of time, next you are going to get 2 megahertz as input. Further, you are going to get 1 megahertz. Further, if you are going to apply, it is going to be decreased. Why it is going to be decreased? If you are going to clearly observe, what is the relationship between the clock and the frequency? Clock and the frequency, you can able to simply write as frequency equal to half of clock. Frequency equal to half of the clock, right? Why? What happened here? You can able to observe this diagram is clearly defining for you, right? So if I say first one Q0 time period, time period of Q0, is 2 times of the actual clock amount. Okay, na? So this is what I have written earlier itself. But if I try to write in terms of frequency, so you can able to write in terms of frequency as 1 by f Q0, frequency, right? So you know the relation between these two, and you can write 2 into 1 by frequency of the clock, right? If I write, so frequency of Q0 equal to frequency of clock by frequency of the clock by 2, right? This is way you are going to decrease, right? So this is what we can call it as division, right? So clock is going to be clock frequency is going to be divided. So clock frequency is going to be divided. This is what we call it as frequency division, right? So we can simply say that this is divided by 2 circuit. divide by 2 circuit. We can say that simply frequency division. Frequency, right? So if I am going to have further, right? This is a kind of how many values it is going to be counted? 4 values it is going to be counted. If I am going to have two flip-flops, it is going to count 4 numbers. It is going to count 4 numbers. If I am going to have 3 flip-flops, it is going to count 8 numbers. Those 8 numbers is from the range of 0 to 7. If I am going to have 4 flip-flops, how many values it is going to count? It is going to count 16 numbers. Those ranges from 0 to 15, guys. 0 to 15. So like this you can able to perform the like we can call as counting operation. Right? So what is the relation between this number of flip-flops used and the counter? If I say that if I am going to have n flip-flops, how many numbers it is possible? It is possible for us 2 power n numbers. 2 power n numbers. Those ranges from 0 to 2 power n minus 1. 2 power n minus 1, right? Or else in other terminology we can say simply these n flip-flops I can be represented as capital N, which should be less than or equal to 2 power n. Meaning that with the help of n flip-flops, with the help of capital N flip-flops, I can able to generate less than or equal to 2 power n numbers. Less than or equal to 2 power n numbers, right? Am I right? If I say that 0 to 15, I can able to generate from 0 to 5, 0 to 10 or 0 to 4, like that, whatever it may be. You can able to generate a maximum of 16 numbers. Those 16 numbers is from 0 to 15. 0 to 15. Now, in other technical terminology, if I say this kind of circuit, I can call it as mod 4 counter. Mod 4 counter. Mod 4 counter. If I am going to have 8 numbers, I can call it as mod 8 counter. Mod 8 counter. If I am going to have 16 numbers, I can call it as mod 15 counter. What is the meaning of mod? Right? If I say 5 or else something, some x mod 5. What is the meaning of this one? It is going to generate the remainder in the range from 0 to 4. That's it. So I can call this as mod 5 counter. If I say that y by 25, if I say it is going to always produce the reminders from 0 to 24. I can call this as mod 25 counter. 25 counter. I hope I understood clearly, right? So I can call technical as modulus counter also. Modulus counter also. Okay, fine. Yes. See, it's not only about we can able to use always JK flip flop. You can able to use the remaining kind of flip flops also. For example, if I say some kind of flip flop, let me take T flip flop. Let me call the T flip flop having some kind of negative edge triggered signal, and we have passed some kind of input as it requires T. And if I am assuming that there is one more kind of flip flop is there, yes, and it's going to produce the Q1 and it is going to produce the Q0. This will be the Q0 bar and this will be the Q1 bar, right? This signal is going to be passed to here, and this value are going to be defined by the bar. I hope you have the clear meaning of the advantage of T flip flops, all those things. Okay, fine. Now if I try to draw the timing diagram for this, how it is going to behave? If I say something like this, so this is a kind of a clock signal, and if I am going to have the definition for the input of t equal to 1, what might be the Q0? Guys? So it is negative edge triggered. See, it's not about negative edge triggered. You can able to go for the positive edge triggered also. It can be your wish. I am trying to take here negative edge trigger, right? So means at this point of time only it is going to be activated. So it will be like this. Yes. Okay. What about the Q1? Q1 is depend on Q1 is depend on this Q0 signal. Am I right? Yes. So this is negative distributed. So at this point of time, it is going to be raised. Yes, this is Q1, right? I hope understood. Now, if I say clearly, this is a kind of a clock, So this is also kind of a clock. This Q0 clock, time period is, if I say the time period is 2 times of the actual clock or not? Yes, 2 times of the actual clock. So in other terminology, if I say in terms of frequency is half of the clock, half of the clock. Okay, fine. What about this one? This is 1/4 of the frequency of the clock. 1/4 of the frequency of the clock, right? If I say for Q1, so time period of Q1 is 2 times of the which clock? 2 times of the Q0 clock. 2 times of the Q0 clock, right? So or else if I say the actual clock, 2 times of the 4 times of the actual clock. And if I try to write the frequency of Q1, 1/4 of the frequency of the clock. I don't want to go for the in-depth about the relation between all these things, right? You can able to understand directly. Yes. So further, if you go like that, it will be work like this, right? So if you would like to say how it is working, counting or not, if I try to draw, see this is one clock, this is another clock, and another clock. If I am going to give the namings for this, so this will be a 0, this will be a 0, this will be 1, this will be 0, 0, 1, and this will be 1, 1, right? Guys, if you try to say at the clock and Q1, Q0, at the clock 0, see earlier diagram is somewhat clumsy. Now here it's at the clock 0, what might be the Q1? Q1 is 0, Q0 is 0. At the clock 2, Q1 is 0, Q0 is 1. At the clock 3, so in terms of number repetition, here I have taken as 2. It will be 1, 0. At the clock next level, it is going to be 1, 1. If you move further, you can able to observe here it is 0, 0. Means it is going to be like this. So I can say that this is also kind of up count. This is also kind of up counter, right? If you move further, where you can able to observe the down counters also, meaning that they are going to start with 1, 1 and they are going to reduce it to the next level. So that is what this definition. It can be a kind of up counter, down counter, or random counter, or whatever it may be the random values. It can start with any number also. Okay, na? Fine. See, if I try to say in some other order, try to observe what might be the values. Think about this one. If I say what is the present states? Present states are Q0 and Q1, right? So if I say the present states Q1 and Q0, what might be the next states? If somebody asks, what you will do, right? So let us assume that the present states are 0, 0, 0, 1, 1, 0, 1, 1. What might be the next states? Next states are something like, if I try to write some other terminology, Q1 next state, Q0 next state. How we are going to do this? So you have to analyze this circuit, right? This circuit you have to analyze and you have to answer. So Q1n value is what, right? Q1 means this value. You have to define it is depend on this particular signal. So first let us try to find out the Q0n. So what is Q0n? Q0n is toggle of, right? As I have given here 1, toggle of the Q0 itself, right? So if I write Q0n is the toggle of Q0, right? So which is going to work for every clock. Am I right? Yes. What about the Q1n? Q1n you are going to get toggle, but this toggle clock signal is what? Q0. q naught, right? Meaning that q1 n is going to be q1 n is going to be, definitely it is going to be toggle. It is going to be toggle, but for what kind of value is going to toggle? It is going to toggle for based on q naught, based on q naught. So when q naught is moving from low level, right? Sorry, edge, negative edge trigger. Negative edge trigger means, negative means what? It is trying to move from uh, high to low. I can say that in terms of 1 to 0. 1 to 0, right? So you have to make sure to understand this particular point. This is very, very important. So I have taken this concept in order to solve the gate question sum. So above all things will comes under general things for theory perspective, but this particular concept is for the purpose of gate thing. So you can able to observe q naught n you are getting directly because of toggle of the earlier state, toggle of the earlier one, right? Okay. What about the q1? Q1 is also toggle of q1, but this q1 toggle, when it is going to be happen? When the q naught is a kind of negative edge trigger. That is what I have written. Okay, fine. So now what you can do now? Try to fill according to these formulas. So q naught n is what? Q naught n is q naught bar. What is q naught bar? This 0, here it is 1, 1 it is 0, 0 it is 1, 1 it is 0. It is 0, right? What about the q1n? Q1n is q1 bar. Q1n is q1 bar. That's okay. But this q1 bar has to be satisfied at what time? At what time? When q naught is changing from 1 to 0. Q naught is changing from 1 to 0. If you are able to observe, q naught is changing from 1 to 0. Am I right? This particular point to this particular point it is changing. When it is changing from 1 to 0, you have to change the q1 value. So q1 value is, it is here 1. Similarly, when it is changing from 1 to 0, as it is changing from 1 to 0, you have to change its value to 0. I have changed. What about these values? What about the remaining values? They are going to be as is. I haven't defined anything, right? When only for this particular case you have to define. So here you will get 0. Here you will get 1, guys. You will get 1, right? So if you are able to clearly observe this particular diagram, this particular table, this is I can write as 0, 1. This is I can write as 1, 0. This I can write as 1, 1. This is I can write as 0, 0. This is 0, 0, 0, 1, 1, 0, 1, 1. So if I try to write in the form of some state diagram, something like counters. See, I have the value of 0, 0, value of 0, 0. When I give the present state as 0, 0, what might be the next state? 0, 1. Next state is 0, 1. When I give the 0, 1 as a present state, what might be the next state? 1, 0. When I consider 1, 0 as a present state, what might be the next state? 1, 1. When I consider 1, 1 as a present state, what might be the next state? 0, 0. 0, 0, right? So this is what we call it as up counter using T flip-flop. I hope understood clearly, right? So I can just conclude here. So the flip-flops I can able to use it for the frequency division as well for the counting purpose, right? That counting can be either in the form of up counting or down counting or random counting, where you can able to use any kind of flip-flops. So the way the clock signals are like operating here, you can able to get its counting operations. Okay. So in the next class we'll try to go for further. I hope understood clearly. Thank you.